So the gradient vector is perpendicular to V. Okay, that's a good start. We know that the gradient is perpendicular to this vector tangent, that's tangent to the level surface. What about other vectors tangent to the level surface? Well, in fact, I could use any curve drawn on the level W equals C. So I could move really any way I wanted on that surface. In particular, I claim that I could have chosen my velocity vector to be any vector tangent to the surface. Okay, so let's write this. So this is true for any curve, well, maybe say for any motion on the level surface W equals C. So that means V can be any vector tangent to the surface, tangent to the level. C, for example, let me draw one more picture. Okay, so I have my level surface. So I'm drawing more and more levels, and they never quite look the same. And I have a point, and at this point, I have the tangent plane to the level surface. Okay, so this is tangent plane to the level. Then if I choose any vector in that tangent plane, let's say I choose, I don't know, the one that goes in that direction, then I can actually find a curve that goes in that direction and stays on the level. So here that would be a curve that somehow goes from the right to the left, and of course it has to end up going up, or something like that. Okay? So given any vector tangent let's call that vector V, tangent to the level, we get that the gradient is perpendicular to V. So the gradient is perpendicular to this vector tangent to this curve, but also to any vector I can draw that's tangent to my surface. So what does that mean? Well, that means the gradient is actually perpendicular to the tangent plane or to the surface at this point. So the gradient is perpendicular. And well, here I've illustrated things with a three-dimensional example, but really it works the same if you have only two variables. When you have a level curve, it has a tangent line, and the gradient is perpendicular to that line. Okay, any questions? No? Okay. So let's see. That's actually pretty neat because there's a nice application of this, which is to try to figure out, now we know actually how to find the tangent plane to anything, pretty much. Okay. So let's see. So let's say that, for example, I want to find the tangent plane to the surface with equation, let's say x squared plus y squared minus z squared equals 4 at the point 2, 1, 1. Let me write that underneath. So how do we do that? Well, one way that we already know, if we solve this for z, so we can write z equals function of x and y, then we know tangent plane approximation for the graph of a function z equals some function of x and y. But that doesn't look like it's the best way to do it. Okay, the best way to do it, now that we have the gradient vector, is actually to directly say, oh, we know the normal vector to this plane. The normal vector will just be the gradient. Oh, I think I have a cool picture to show. So, okay, so that's what it looks like. Okay, so here you have the surface x squared plus y squared minus z squared equals 4. That's called a hyperboloid because it looks like what you get when you spin a hyperbola around an axis. And here's its tangent plane at the given point. So it doesn't look very tangent because it crosses the surface, but it's really, I mean, if you think about it, you'll see that's really the plane that's approximating the surface in the best way that you can at this given point. It is really the tangent plane. So how do we find this plane? Well, you can plot it on a computer, but that's not exactly, how you would look for it in the first place. So the way to do it is that we compute the gradient. So the gradient of what? Well, the gradient of this function. Okay, so I should say this is the level set w equals 4, where w is x squared plus y squared minus z squared. And so we know that the gradient of this, well, what is it? 2x, then 2y, and then negative 2z. So at this given point, I guess we're at x equals 2, so that's 4. And then y and z are 1, so 2, negative 2. Okay? And that's going to be the normal vector to the surface or to the tangent plane.